यूट्यूब पे कनेक्ट कर दिया।
जी जी सर, लाइव चलेगा।
आजकल ये बड़ा खतरनाक हो गया। आप कुछ ही बोलो, आपका यूट्यूब पे जा रहा है।
आप कहाँ से म्यूट करोगे? ये now we will start today's session. Healthy good morning to all of you for offline session. ATAL FDP program, hybrid microgrid opportunity and challenges for renewable energy resources. I am Dr. Shivam, Assistant Professor of Electrical Engineering Department, NIT Kurukshetra, co-coordinator of the ATAL FDP. Heartily welcome Chief Guest of the day, Professor Mukhtiar sir, Professor, Electrical Engineering Department, Delhi Technological University, Delhi, Coordinator of ATAL FDP program, Professor Ratna Dahiya, Coordinator of a School of Renewable Energy and Efficiency, Professor in Electrical Engineering Department, NIT Kurukshetra, and faculty members and participants of the event. The primary objectives of the ATAL FDP is to provide a national forum to the faculty and research scholar to share the basic knowledge with an objectives of understanding the concepts, aspects of penetration of renewable energy sources, electrical vehicles, and with hybrid microgrid operation. Now, I would like to address of today's session Professor Mukhtiar sir. He is a professor in Electrical Engineering Department, Delhi Technological University, Delhi. He is working as a professor with the Electrical Engineering Department, Delhi Technological University, Delhi. He received the BTech and MTech degrees in Electrical Engineering from National Institute of Technology, Kurukshetra, in 1999 and 2001, respectively. He earned his PhD degree from École de Technologie Supérieure, University of Quebec, Montreal, Quebec, Canada, in 2010. Professor Singh is the recipient of IEEE Student Scholarship for one of the best paper in 34th IEEE Conference of Industrial Electronics Society, ICON 2008, held at Orlando, Florida, USA. He is also the winner of Researchers Merit Scholarship of the University of Quebec, Canada for 3 years consecutively in 2008, 2009, and 2010 for his excellent research work, culminating to PhD. Professor Singh is actively associated with IEEE and had been treasurer of IEEE, PLS, IES, Delhi chapter for 2015 and 2016. He had also been the general chair of 5th and 6th IEEE Power India International Conference, PICON 2012 and 2014. Professor Singh is also recipient of Research Excellence Award for DTU for the year 2017, 18, 19, 20, and 21. According to 2016 survey conducted by the Council of Canadian Academics, you are an author of one of the top 1% most highly cited papers in your field worldwide. Your area of research includes power electronics, power quality, renewable energy and intelligence, controllers. He is also in the technical advisory group of leading renewable energy companies like Enercon India Limited, Mainframe, Solar, and have also been technical expert for PSUs like Coal India Limited and Power Grid Corporation of India Limited, PGCIL. He is also in the panel as a subject expert of TCS Iron, which is one of the world's largest entity in the area of cloud-based IT solution, which is provider for various industrial academic institutions as well as prominent examination board. Professor Singh is also the editorial board of IEEE Transactions Electrification Committee. As per the recent survey conducted by Stanford University Healthcare Database, Professor Mukhtiar Singh has featured in the top 2% scientists in the world by securing 1867 rank in the area of electrical and electronics engineering. So with this, today welcome sir for this session. Thank you, sir.
पोस्ट बना दीजिए सर को।
Sir, you host.
ठीक नहीं कर रहा सर, होस्ट है, होस्ट ये है। Okay, good morning to all of you. Yeah. So I'm very thankful to Dr. Shiva for providing me an opportunity to give my talk. And Today I am just going to deliver something about how the power interface can be applied and harvest the renewable resources. And mainly the renewable resources nowadays are going to integrate their distribution level network. So we are them distribution generation. So distribution generation may also have some diesel set in the system. So diesel set, of course, is not a renewable energy source, but now we are also looking for the another aspect of how to complement the intermittency arising in renewable energy sources, so that a diesel set or battery energy storage system or any reliable source having sufficient backup is required to be there. So distribution generation now a very appropriate term in terms of integrating renewable energy sources at different locations. So coming out to this part, so I'm going to introduce a little bit why we need to have that smart system. Only then we can harvest the maximum energy. So smart grid concept is there already, but I'm going to a little bit introduce. Then we will carry on forward. So features of smart grid are going to be there. Then issues related to distributed generation, and then control of those generations with the different control algorithm and how the different sources having different power generations at either DC voltage level or AC voltage level. But those voltages are always going to change variable. So those voltage cannot the power coming from those kind of states cannot be readily applied with load, because load are said to be at either a special voltage and frequency, depending on which kind of load you are having. So we have to always need to process the power only before feeding it to a load. So control of distributed generation according to our requirement is very utmost need of the hour. And then how the system or concept of smart grid looks like. So you are having the electrical infrastructure and you are having intelligent infrastructure. So intelligent infrastructure means you need to have remote sensing, RTU, remote terminal units, or PMUs, or other devices going to monitor the real-time health of different nodes. Nodes means we may have bus, we may have generating facility, we have transmission network, or we may have the distribution power generation facility like a wind farm or solar power plant, or maybe another small microgrid, or you can have tidal energy source or any source which need to be monitored, which output power need to be monitored, its forecast need to be monitored, and it has to be sent to the control room, where the perfect management tools are need to be there, because always need to certain the load demand, and once load demand is there, according to you can specify the amount of power which can be generated from the conventional generation. But now which is there, like since we are going to introduce more and more resources in future, right now we started from 67% penetration of renewable, and now it contributes almost 18%, 80 to 20% of installed capacity of total Indian energy we are talking about. So 18% renewable energy penetration is a huge amount, because of the challenges introduced by the intermittency of the renewable. Because renewable is sometimes there, sometimes not there. So it is going to create more stress on the power system operator, that how to manage the power demand within the generation scenario, changing generation scenario. Because generation is also changing and demand is also changing. So to have a perfect match between demand and supply, only then you can maintain the voltage and frequency. If there is demand and there is supply, if both the powers are same, then you can make a perfect balance between the supply voltage and frequency. But if mismatch is there, then the voltage and frequency of the system is going to change. So that is the major drawback of renewable energy sources. So now what we are thinking of, we must have smart appliances or smart devices which can monitor the real-time data of renewable energy, which can estimate the power going to be generated by the renewable. So that accordingly we can have our asset management tools program. So that nowadays we have to follow a pattern where generation is followed by the load. So that is the smartness. Otherwise, conventional approaches, we are going to first forecast the load, and according to the load forecast, we are going to control our generation. So load is going to be followed by the generation in present scenario. But in future of smart grid, generation is going to vary because of the renewable energy sources. So that generation need to be followed by the load. So now, according to generation, we have to control the load. In previous case, according to the load, we were controlling the generation. So that is the difference between the both the kind of smart grid system or normal system. So you have to really look about the if you used to control the load according to that, you must have remote control unit also. We must have remote data monitoring unit also, and we must have prioritization of the load. Prioritization of the load means you have this priority load, you can have most priority load, you can have deferable load. Some of the load can be deferred, just like if I'm thinking this way, and I can define the priority. Lighting may be my priority, then second priority may be my fan. AC can be my third priority. So sometimes I have to run the show, and all these electronic devices they must be operating. And suppose I'm managing this power requirement of this group through a solar photovoltaic system, and due to the condition you can see outside, it's a foreign condition. Power generation by the solar is going to be minimal, and you must have a sufficient battery backup. So that battery backup plus small or little bit power coming from the solar, from that energy you have to meet your this load demand. So what you must do, your priority must be that my audio video must be working perfectly. Then small comfort level, illumination level, it must be maintained. Of course, now it's a winter season, so you don't need a fan and AC and other. Heater may be required, but heater is the lucky factor. You can put up on the so it is the most preferred load, most you can say. So you can say that according to the whatever power I am having, it is those power limits I have to manage my load requirement. So according to generation, now you are controlling the load. So this is smartness. Otherwise, whatever load is there, you have to manage it by having more generation. So in that case, you must have a controller generation, and controller generation can come in the form of diesel generator or some other source to provide one of two or one of four. Case of one of big power grid system, we have that. So all the things are going to be there. So to introduce all such kind of smartness, you must have you are already having conventional power grid or power system network, transmission network, system, everything is there. And then you must have internet infrastructure. So if you are going to combine both of them, then it becomes a smart grid. So you can say that it's a marriage of smart devices, smart measurement devices, intelligent electronic devices with the conventional transmission network. So smart grid is a marriage of information technology, data intelligent communication devices with conventional grid to make it more efficient, economical, reliable, and secure. And according to that, you can have asset manager, grid control, data collection and local control, and communication sensors. All these are the part of the smart system, which are going to be there to make you competent enough or capable enough to utilize the renewable energy sources to maximum extent, so that you can minimize the consumption of fossil-based power generation. It may be coal, or it may be diesel, or it can be any other hydrocarbon-based power generation. So you have to minimize that power generation, and you have to increase the renewable power generation. And with this can be done with the help of smart intelligent control devices, and power electronic devices are one of the most important building blocks of harvesting renewable energy sources, through which you can control the power. You can perform the various maximum power point tracking systems and other complex algorithms which you can implement through those devices. But ultimately, power electronic devices are going to be there, so that you can always try to match the load impedance with the source impedance, so that we can have our maximum power generation. Either irrespective of whether it may be solar, it may be wind, or it can be any other fuel cell or any other device. But ultimately, your aim is to utilize or generate the maximum power coming from the renewable energy sources under the prevalent condition. So this is the one of the requirements. So how the smart grid is different? So today and tomorrow, so you can say that it enables the consumer participation. So little price visibility, time of use, price in rare and fixed choices. So today you don't have any choice. You are bound to take the supply from the state electricity board, and whatever supply and whatever quality of supply is available, you don't have any choice. But in future, if you are having your own renewable power generation coming from the solar, and you are generating more than what you are looking for, you can sell it to the grid, or you can store it to the inside the battery also. So in future, you are having the choice, or there is a RESCO, renewable energy sources development company also. So some nowadays players are coming which are installing the renewable energy sources in a commercial way, and they are selling that electricity to the consumer. Consumer can be individual or can be developer. Like I think NIT are selling for a plant which is installed by some company, and the amount of units being generated by that company only those are going to be built by NIT. So in that way, some company, new companies coming, they are generating the power from renewable energy sources and selling it to the consumer. So consumer is now having the benefit in terms of if there is no electricity, at least some sort of energy is coming there, backup is there, and even backup is not there, it is connected to the grid. But first, it is going to build by the renewable energy sources, and then on by the main power electricity board or the utility supplier which is giving power at those steps. So that is the difference is coming out, and in future more and more players can come and you can bargain. Just like if you going to if you are going to market, going to purchase some clothes or something, so you build so many stores and according to your choice, according to your requirement, according to your economic prices and everything, you purchase as per your choice. So that choice is going to be inbuilt in future in the energy sector also, and individual power consumer can have the choice to buy the electricity from the supplier as per his own choice. So that is the choice is you have to ensure whether the supplier is good in reliability of the power, efficiency, all the things are there. Just like a wireless network, mobile network, you are having video, you are having BSNL, you are having export that is or marketing or whatever or the other systems are there. So you are having now the choice. Again, you are having BSNL or the other state sponsored channel provider. So that kind of shift in utility services, which according to communication or technology, the same is bound to happen in energy sector also in the near future. And now this smartness introduced by the intelligent devices, including power and converters, is going to make a big difference in harvesting in the world. So now tomorrow you can have full price information from many plant prices and option to buy and sell, and it accommodates generation storage. So that dominated by central generation, little distribution generation, demand response management, storage, or renewable. So this is the scenario today. But in tomorrow, many clubs and play distributed generation, energy resources complement central generation. And so that means it enables new markets, limited wholesale markets, not well integrated, which is the current scenario. But tomorrow, mature, well integrated wholesale markets, growth of new electricity markets, because new players are about to come in future. So according to that thing is there. And needs people needs also. So focus on outage, not power quality, PQ priorities with a variety of quality prices, options according to the need. Because nowadays scenario is something like suppose now there is the option if a consumer having more than 1 megawatt load demand, or like a load commercial setup buildings, they are having a choice. If they are having 1 megawatt power supply, they are having the choice, they can purchase it from anywhere in India. Because now India, all the grids are they can be together, so they are forming the grid. So let us say if I am a 2 megawatt load requirement facility, so I have choice. I don't need to purchase it from the hydroelectric board, which is giving me power price that can be for I can look for some another option, and that's why I'm having some power from Adani, which is offering me at 14 per minute. So I can purchase it from there, and what then now comes down to the cost, material transfer. It is just like I'm going to purchase some food grains from nearby market, or I'm going to purchase from the MP. So if I am coming taking it purchasing from MP where the prices are very low, but the transportation cost is there. The highway through which that goods have to be transferred and coming to my location. So I have to pay for the toll tax plus transportation. So highway taxes plus transportation. So similarly, if I am going to purchase electricity from a supplier whose facilities, generating facilities may be in Chhattisgarh or maybe other location where coal is easily available. So that's why the electricity is easily available. So if I have a commitment with the Adani Power, so the electricity is going to flow from Chhattisgarh to my location at Microgrid through different transmission networks. So in real time, that highway toll tax means the electricity infrastructure or transmission line network which I am going to apply for getting power transfer from Adani to my location. So that purpose I need to pay only, and whatever agreement I have made for the electricity purchase from each station, that I have paid. So 4 plus some toll taxes, etc. So ultimately coming to be 6 rupees, but still comparable to very cheap will compare to 10 rupees, which I am getting at local supplier. So that kind of choice is available with the bulk power consumer. But individual consumer or domestic consumer still it is not there because the electric demand is less, and to compute all such things is very difficult. But now you have the option to install your own grid tied solar power plant. Here, the power which you are going to generate can be implied in real time, and if you are generating extra power, then it can be sent to the grid also. Or throughout the year, it's a power bank. You are not going to pay, but within a 1 year, you have to settle down the account. So that is the major advantage. So how the smart grid difference? So optimize asset and operate the efficiency, and you know that it is the optimization of renewable resources. So that is one of the best ways. So data integration with asset management, but integration of grid intelligence with asset management software. Self-healing capability is there, some cyber attacks or some other things, if they are coming in picture, then your that the grid can be because more intelligent equipment you are going to introduce in your current system, then there is a chance of damage, those kind of vulnerability in terms of cyber attack or some hackers there. So you have to be more secure and in that. So, but it prevents disruption, minimize impact, restore stability. So resist attack also. So vulnerable to terrorism and natural disaster. But if you are having a different kind of restoration capability, you can in small location you can operate as a microgrid also. If you are disconnected from the main grid, then whatever resources or generating capacity you are having locally in that particular area, according to that, you can keep on feeding the local load in the form of microgrid. So that kind of freedom is available with the integration of power electron-based renewable resources, which are primarily stored there in normal grid. So therefore, that does detects and mitigates and stores stability and efficiency. So these are some of the advantages. So smart grid will be having active participation of consumers. It accommodates all generations and storage options, and enables new products, services, and markets. Provide enhanced power quality. Power quality, as you know, that the reliability of the electricity is one of the major parameter of quality of the power. Then how much voltage fluctuation you are having, how much frequency fluctuation you are having, that is also a measure of quality. Because any difference in voltage frequency from the limit is going to affect the performance of the appliances or devices you are to connect to that supply. So the quality of power supply is very it must be ensured actually. So that is also going to be one of the more. So and then optimize asset utilization and operate efficiently. As I have told you that according to the whatever assets you are having, it takes care of the economics as well as pollution impact and other things, so that it can utilize the maximum power of the renewable first, and only later on it is going to utilize the power from the conventional generation. So that is the advantage is going to be there. And get anticipate and respond to system disturbance and time during security, which I have told you that if some part is getting some attack or some protection issue, it can disconnect that part and the remaining part can still keep on kept on energized. And later on it can detect if the system was healthy, then it is going to connect it again. So self-healing capability is there. So operate resiliently against attack and natural disaster. So these are the some thing which is expected from a smart grid. So you can say that active participation of consumer, the consumer is aware of the foreign, how much to use, when to use, time of use, how much to pay, and the consumer are trying to have smart energy meters, smart home appliances, and this. So now coming to the smart meter, smart appliances, generation, airport company, they have the capability of controlling their active and reactive power, energy storage system like private ultra capacity electric vehicle, plug-in hybrid vehicle is there. Now a very case scenario may be there that in a home you are having solar plant installed on the rooftop, you are having smart appliances, you are having electric vehicle. So electric vehicle, as per the report from MIT Boston, they have conducted a survey throughout the 2 years basis, and it has been observed that throughout the 24 hours, your passenger vehicle or electric personal vehicle is going to fly only more than only for 2 hours daily. So that means 22 hours. For 22 hours, it is sitting idle at your either at your workplace or at your home. So the energy stored for the battery backup is there. Battery stored inside the electric vehicle is readily available to take care of the power fluctuations introduced by the renewable. So if you are generating more, it can be given supply to the battery of the vehicle, and during the night time when there is no electricity from the solar power plant or any other means of generation, then the electricity could be extracted from the vehicle to suit your home requirement or office requirement, or if you are outside, you are camping somewhere, or you are whatever thing, there is software which can keep on supplying a small load demand. So plug-in hybrid electric vehicles having high battery backup installed inside the vehicle can be very helpful in mitigating the fluctuation or intermittency introduced by the renewable energy source. So that is one of the advantage also. In future, people may be self-reliant. They will be having their own microgrid. They are having their generation from the solar plant. They are having small little bit vertical set, and then this electric vehicle. That's it. You don't need anything from outside. Everything will be managed by locally. So very small dependency on that state electricity board will be there. It is just like now what is happening with the VS. It is the same thing may happen to the state electricity board in future. People will not going to prefer the electricity from there. Only in remote location. Just like if you go to some remote area, the Geo or other mobile network may not be available. Yes, it will be working over. So same thing will happen. If you go to remote area, you will be finding state electricity board, because the power players will come only in the metro city. Just like Tata Power, BSPs are already there in Delhi or Mumbai. Because the customers are willing to pay. But in rural area, the situation is totally worse. It is very difficult to charge money or to pay to charge a tariff from a rural area, and so many other constraints will be there. I'm not going to you can say I'm not going to make any statement, but you know the situation. People in city or metro cities, they are because they need something. Who is going to provide the better solution? They are going to avail that. That is the real requirement. But in rural area or some other remote area or that rural background, they will prefer the cheapest or free of cost electricity must be available. It is all because of the economic situation. So they don't bother about the quality of power, but they are looking for the power. So there will maybe different scenario. So ultimately, these players are already there. Private players are already there in liquidity market sector. So public utilities will be there, but they will be only catering the need of rural area or rural places. Also, the others are going to be taken care by private players. So communication technology and standards, automatic meter infrastructure, PMU, then and all these things are required. So coming to that, so now in future the smart grid is going to have all those aspects. So in future you are having a factory which is connected to so you see that this is a big factory over here. This is transmission line network. Then you are having the demand management store systems also there. Renewable power coming from wind. And then smart homes you are having, wireless systems you are having. So all those things, transmission structure, networking, operation control, failure measurement units, wind turbines, everywhere, and or small micro hydro or other things are there. So everything is going to be there into the system, and they are working all together, and their sole motive will be to utilize the maximum utilization of renewable resources and to minimize the fossil fuel usage and what we have rated the policy effect, and all those things have to be done with the help of intelligent from devices plus power interface. Only then it can be achieved in a full way. So smart grid drivers are operational efficiency, increase operational productivity, reduce capital and operating cost, improve physical cyber security. So customer satisfaction is also there. So because of the improved reliability, consumer empowered to control energy usage, tighter communication with utility and additional services. And then you are having environmental impact also because it reduces provide or skill meet or exceed regulatory requirement to increase environmental options for consumer. And then energy efficiency, so optimize energy save, many growing energy demand and extend asset utilization. So all these are the different benefits of which the smart grid is going to introduce. And now coming to the picture, how the digital generation are there and what kind of impact they can be having in our day-to-day life and how to harvest that energy. So these are the different solar distributed generation. It can be in the form of solar photovoltaic system. It can be wind turbine. It can be micro turbines, micro hydro turbines. It can be storage technology or storage energy stored inside the electric vehicle. So different aspects are there, and every where the power is available, and the sole purpose is to utilize the maximum benefit out of the renewable energy source and to minimize the fossil fuel usage. So these are the going to some major objectives. So coming to the motivation, so recent trends towards renewable energy sources based distribution generation is going to there, and development of new strategy for the operation and management of electricity grid incorporating distribution generation, empowerment in reliability and quality of power supply, and restructuring of the grid leads to new management structures like microgrid. So restructured part, small microgrid, they can form a grid, and then they can also disconnect themselves from the network, and then they can keep on feeding their required load. So this is the layout of a grid interactive distribution generation. So grid interactive distribution generation, you are having a utility grid here. This is your grid. You are having a small microgrid also, which is having its own generation, own load, own generation load. So 3-4 generation load is there. So this is a microgrid, and a switch is also provided. This switch is automatically going to disconnect itself from the main grid whenever there is some fault or some fluctuations or some disastrous natural calamities or whatever may be there. So if the something some your network got means having some disturbance, then this switch is going to disconnect itself from the main grid, and now this becomes a small geographical area where the generation is going to be utilized to feed the local load. So that is the smart grid concept. Otherwise, you are having a wind turbines, like here, you are having solar power plant, you can have fuel cell generating facility where hydrogen and all those things can be there. You can have micro turbines, or that is a big sugarcane factory or other factories which are having CHP power plant. Are you aware about that? Every big power plant, big plant, they are having some boilers and all those things, and some are generating the byproduct also, no? Byproduct, just like sugarcane wastage there. So that is again utilized to generate the electricity. So that kind of co-generation facility which are existing in a big power plant, they are also feeding electricity to the grid after meeting their own load demand. So those kind of facilities are also part of distribution generation. So all those things are going to be integrated in a main grid. So because you know this is a DC bus which I have told you there, solar is going to generate electricity at variable DC. If it is a variable speed wind turbine, then it is going to generate electricity at variable voltage and variable frequency. And similarly, if you are having fuel cell or battery which are having different level of DC voltage. So different level of DC voltage, different level of AC voltage, and different frequencies, how they have to be connected to the same grid. So you have to bring them first on a same scale. So means all variable AC had to be converted into DC. Variable DC must also be converted into fixed DC. So either you need to have AC to DC conversion or DC to DC conversion. So that's why you are having in wind turbine, you are having AC to DC conversion here. In solar, you are having DC to DC conversion here. Or in also that the fuel cell is already giving you DC supply. It can give a DC to AC or DC DC conversion also. So ultimately, whatever is coming out is a DC. And then you have to convert it into AC. So AC with the help of DC AC inverter connected to the transformer and connected to the grid. So this is the whole flow of power, means whatever is coming out, the power coming from here, it is going to be converted to AC, and then it is going to connect to the AC bus through transmission and through big generating facilities. Load can be fed at DC itself, or it can be connected to AC bus also. So it becomes a hybrid system also. So you see that the different renewable energy sources, they can be combined together irrespective of their nature of voltage, their level of voltage, and their frequency is also variable. So different domain renewable energy sources, they have to first bring to a common platform. Common platform is what? DC voltage bus, DC bus voltage. So let us say I am having just if I wish to connect all this power to a 400 AC voltage supply. So my DC bus must be at least twice of the RMS voltage. So 400 means you can have almost 800, 760 to 800 DC link voltage. So for that DC link voltage, you have to convert now the variable AC coming from the wind turbine into 800 volt. Similarly, the variable voltage which is coming from the DC power plant, solar power plant, it has to be converted into DC. So DC. So everything need to bring on the DC bus. So different, it is just like different sources are injecting current at DC bus. And then from that DC bus, that current have to be extracted. and given to the AC bus. And that had to be done with the help of grid interactive or grid tied inverter. So grid tied inverters are required, which are going to connect it to the main grid. Or if the main grid is failed, there is some fault, then you must have a microgrid structure, which can again reorganize its structure in such a way that it is going to meet the local load demand. So that is the smartness, that how different energy storage systems have been utilized effectively to meet the load demand and with having minimum carbon footprint, with maximum utilization of the renewable. So that thing can be done only with the help of power electron devices, because at every stage DC-DC converter or AC-DC converter or DC to AC converters are required, and they need to be done with the help of smart devices also. DSP, microprocessor, microcontroller, FPGA, all those things are required, which are going to measure different voltage, frequency things, and then according to that some control algorithm you have to apply, and then switching pulses through PWM and going to apply at the terminals of the converters. This one. So the power electron interface for solar photovoltaic system, I'm going to introduce first SPV systems. So SPV systems, you can see that in the case of SPV system, the power is generated by variable DC voltage. The power electron interface is required to convert the variable voltage into constant grid voltage and frequency. So variable DC link voltage had to be converted to grid voltage and frequency. And different kind of power converter configuration may be used for such type of applications. However, DC-DC boost converter and grid interfacing inverter are two important building blocks, because variable DC voltage coming from the solar need to be converted into fixed DC, and then that fixed DC is to be converted into grid voltage and grid frequency. So the DC-DC converter is used to raise the DC voltage level in addition to control of SPV system, incorporating maximum power point tracking. So that DC-DC converter is not only raising the or not only boosting up the voltage coming from the low voltage solar panel to grid interactive high DC voltage, and then it is also going to implement the maximum power point tracking algorithm also. So both these parts are going to be utilized, and similarly the grid interfacing inverter is used to inject the generated electric power in synchronous with the grid voltage. So whatever power you are generating from the solar panel, it had to be injected into the grid at grid voltage and grid frequency. Grid synchronization means you are injecting the current in synchronization with the grid voltage and grid frequency, because grid is a big ocean. You cannot change its voltage and frequency. You can only inject into it. So just like infinite bus system, infinite bus bar system. If you are from electrical background, you know that what is infinite source. Infinite source means whatever amount of energy or power you can supply it in or supply it out, take in or take out, no effect in terms of voltage and frequency. So it comes out to be infinite bus. So grid is a infinite bus. You cannot change its voltage or frequency. What you can do, you can only inject or you can evacuate. So that's why we call it voltage source inverters are required for that purpose. So grid interfacing inverter is one of the major device which is responsible for pumping in power generated from the any renewable to the grid. If you are having doubt, please keep on discussing. I can have. So different types of integration may be there, just like SPV cell. You can have standalone system, you can have grid connected system. So standalone system means you are not connected to main grid, you are having small microgrid type of structure where with you are having with or without energy storage system. You can have some hybrid energy storage devices also connected with your system, where wind turbine or with the power generation or with diesel set, you can be there. And appliances, small appliances, AC standalone system, DC standalone system. So that kind of thing can be there. with the help of a within a standalone system. Grid tied system, you are directly connected to the grid and via home a grid network or via your device or some which is there, which is continuously monitoring the power flow. Either it is inside or outside. Inside home, you are drawing power from the grid. Outside home, you are feeding into the grid. So those kind of facilities are already there. So this is some sort of integration which is possible. Coming to standalone systems, you are having like your solar cell and DC load. Just like your wristwatch and calculators powered by the small solar thing. Have you seen it? Or even a solar pump. Direct electricity coming from that, power is going to be, or water is going to be evacuated. But the output of water discharge from pipe depends on the amount of electricity being provided by the solar panel. So the discharge is not going to be fixed. Just like in a conventional tube well, which is being run by a motor running at fixed speed, taking power from the grid. So because fixed power being supplied, so constant discharge of water is coming out from the tube well. But if you are having a solar powered submersible pump, then the power generated by solar depend on the irradiation level. So if radiations are changing, the power is changing. Power is changing, the speed of the machine is also changing. So if the speed of the machine is changing, then ultimately the output of means flow of power, flow of water, discharge of level of water is going to change. So these are the directly fed loads actually, where it doesn't matter a variation in discharge level or something, because ultimately the power is coming out free of cost. Water is coming out free of cost because of the solar panel. So these are the directly connected loads can be there. You can have MPPT control algorithm in between just to have maximum power generation from there. And then you can have small battery backup also connected to meet out the fluctuations or to enhance the reliability of the supply. So that thing is also possible with the help of this thing. And then you can have small DC load as well as AC load can be fed. So DC AC inverter can also be installed inside the system. So all those things become a standalone system where different sources, different battery backup may be there. AC load can be fed. DC load can also be fed simultaneously. So then grid connected system, you need have MPPT charge controller. So DC, that means DC converter is going to be there. Then you are having DC AC converters, so you can feed it to grid, and simultaneously you can also supply it to the AC load connected at the point of common coupling. So hybrid systems, again DC backup, or you can have diesel set, or you can have wind turbine also. Different hybrid means different combination of sources and meeting the common target to keep on feeding the DC load as well as the AC load, depending on if you are having DC AC converter also or DC DC converter also. So building blocks of SPV, there are two major building blocks of solar photovoltaic system. DC DC converter performs maximum power point tracking and raises the DC link voltage. This is the main role of the DC DC converter in solar photovoltaic system. And then grid interfacing inverters, so it does the grid synchronization. And also because the concept I have introduced first time actually, and I also got best paper award for that in Florida, USA in 2008, Industrial Electron Society of IEEE USA. So this was the concept means active power, reactive power, and load hormones can also supply by the grid interfacing inverter simultaneously. Because in most of the time, if you are, let us say, if you are having 10 kilowatt solar power generation and 10 kilowatt inverter is there, but most of the time you are generating only 20 or 30% of your nameplate capacity or 60% of your capacity. So rest of the power electron capacity is still available in an inverter. So for that remaining capacity, I would like to support the to keep on supply the reactive power demand or a load harmonics of a nearby load. So this is not very good for small system, but if you are having a utility scale power plant of solar photovoltaic system or wind farms where such facility is available. So up to certain extent, those devices can be utilized as a STATCOM or DSTATCOM. So that you can also keep on feeding the energy generated from the renewable. At the same time, you can also meet the different power quality indices required for making it better. And now it is a standard almost. Now, in the earlier scenario, the renewable energy sources have to get disconnected from the main grid in order to prevent themselves under the fault condition on the grid. And again, they got connected when the systems improves. But now this tendency is not there, because faulty means you need to feed the reactive power. So now those converters are required to keep connected, and they must prevent the flow of active power while utilizing the capacity for supplying the reactive power and harmonics. So we call it low voltage ride through capability, LVRT capability. So the system are now not required to disconnect, but they have to support the grid when it is in need. Fault means usse kuch galti ho gaya, it needs some support. Just like I am doing some business, I lost my money, so I need some support from outside. So it's just like a perfect picture of it is selfish nature actually. In previous case, where during healthy condition, all those smart that power that renewable energy sources are connected with the grid. So the fluctuation is taken care by the grid. Means when they are generating less, the grid can give the deficit amount of power, and when they are generating more, it can absorb that one. So that is the grid is tolerating everything. But when there is a fault on grid side, those small renewable energy sources, they cannot meet the grid challenges. So now what the norms are, that whatever capacity those resources are having, up to that capacity, they have to supply the reactive power, or they have to supply the load harmonics or something which are a reason for the fault. So up within the their limited capacity, they have to supply. So it is just like a just like microgrid also having the same structure. When the system is healthy, it stayed connected with the grid. But when there is some fault, it got disconnected itself from the grid, and it keep on feeding small loads which they are having. So it is just like a parental hierarchy, just like have you seen that Bhagwan movie? Amitabh Bachchan and his 3-4 sons, all these are the loads actually, and Amitabh Bachchan is generation in initial stage. So whatever demand is coming out from there, he is supplying everything to their son. But in the meantime, there is some fault. Fault means Amitabh Bachchan got retired. He is not having sufficient future plan, funding, generation. So now he is dependent on the microgrids. Microgrid were his sons, but they are having their own families, own generation load. So in the time of crisis, they disconnected themselves from main grid, and they have their own happily microgrids. Apna family mein, they were very happy. They were very happy within their own families. So the main family comprising Amitabh Bachchan and his wife. So those are not going to be supported by those microgrids. So that is a selfish kind of nature. So microgrid and main grid, that is the difference. Grid is always there to support the microgrid, but reversal is not possible. Whenever some crisis is there on the grid side, microgrid is not going to support it. That is the thing. So that is the major difference between grid and microgrid. Okay, you are getting it, you guys? Really? You understood? Okay, thanks. You make my day. So different MPP techniques are already there. So the efficiency of solar panel increased by maximum power point tracking algorithm, because as the irradiations and temperature varies, and the MPPT of solar panel also varies. So maximum power is obtained from solar array with the use of MPPT algorithm, and different MPPT techniques have been proposed in past to track the maximum power that is generated by PV array in different environmental conditions. MPPT techniques vary according to their different working algorithms, parameters, and equations which are used, and several MPPT methods have been studied and researched. And the following are the few MPPT techniques which have been introduced here. Among all these techniques, the most commonly used technique is hill climbing and perturbation and observation method. So these are the perturb and observe climbing. So some of you are maybe working. You can also have gone to that one. This is also incremental conductance based MPPT method. So types of DC-DC converter, normally we are having a boost because DC side, solar side DC voltage is low, and that another side is on grid side or DC output side, it need to be high. So you can have isolated type system, isolated where the high frequency transformer is there. So grid side disturbance is totally isolated from the solar panel or vice versa. So you are having that interleaved to boost converter. So they are connected in parallel actually. So in that way, you can have n number of such devices just to increase the current power rating. Voltage remains same in parallel, only more devices, so means more current through those are going to be more such type. So you can say more current can be there. So in that way, you can arrange the thing. And ultimately, you are having a power here. So either you connect it to a main grid with the help of AC-DC converter, DC-AC, sorry, or you can connect to a battery, or you can connect to a load. You can do all such things, which is possible. Capacitors to stabilize the voltage, actually. Or these are also, you see, these capacitors, these are the bridge rectifier actually. Where? This one? This? Yeah, these are required to stabilize the voltage actually. Because some within the switching cycle, in every power electron device, this is the major requirement. Within a switching cycle, the capacitor charge and discharge. So that fluctuation must be kept minimum. And this can be done with minimum with the help of energy storage device. So capacitor is also one of the things, because capacitor doesn't allow the sudden change in voltage. Just like the inductor doesn't allow the sudden change in current. So sufficient capacitance is always required to minimize the voltage fluctuation. Because if the voltage fluctuation is taking place, and that is to be done for a switching cycle. Switching cycle means on, off, on, off. So regular voltage may be like this one, but this is the on top of it. Means before it is just like 100 volt, 100 going to 110, coming to 100, coming to 9. So this kind of, so higher the switching frequency, more this one will more lesser will be repulsed, or more capacitance also means almost constant DC. So constant DC required for constant rectification also. Otherwise, any fluctuation here, the fluctuation will appear in the voltage here, the AC voltage like this. So constant fixed voltage, DC voltage, that means fixed rectification and fixed all the things. So this is the control of DC-DC converter, and you see normally actual reference voltage and actual output voltage given to voltage regulator, then whatever load you are having, and this gives you regular load current reference. So IL reference and current regulator, and current signal is superimposed on this one. So you are having this one for upper device. You can have a complement of this for lower device also, if you are having buck boost converter. So this is they are having outer voltage loop and inner current loop. Current loops are supposed to be much faster than outer voltage loop. So first you have to stabilize the outer voltage loop, then you have to stabilize the inner current. So in that way you can have, and these are the different MPPT points, different on 400 watt meter per square, 600 watt meter per meter square, and so different radiation level according to different PV curves. So peak point, if we are combining, it becomes a power becomes a cubic function of the voltage. Yes. Which one? Huh?
Is it coming from the input coming from the inductor current in the converter, or is it coming from the PV?
No, the reference voltage coming from my output, and load, yeah, and load current is coming from the reference current which I am drawing actually. The,
So how do you do that?
I will show you in block diagram next.
So you said there is
Yeah, yeah, yeah,
this one is different from them.
yeah. This is different from there. I will show you. I will show you next slides. I will show you that your queries. Okay. Just I'm going for washroom. I'm coming back. Why that you note down this? You can have this one. I will show you. Okay, coming to your point, I'm going to discuss that slide first, then later on I will proceed. Okay. Mhm. Is it visible now? Okay. This diagram. Okay, coming to your point. So here you see this what I am having the solar panel here and the power coming here. Okay. You see the voltage measured at this point, and current is taken from voltage measured from the VPV solar panel, and the current is taken from here. So both voltage and current, they are DC quantities. So multiply, they are giving you a power, PV. And one curve which you are having here, just like that, P. So this curve you are having, na, with respect to voltage. So one this voltage given to this curve also. So it gives you a P reference. So actual power which you are generating for the solar panel and reference coming out from the curve of that solar, both are compared, and the error is given to I. Error is given to Pi. So it gives you an idea about how much current you can draw, optimum value of the current which you can draw from the solar panel. So this is the reference current and actual current which you are drawing from the solar panel. So both again need to compare, given to a Pi, and output is again superimposed on the PWM waveform, and the pulse is applied to leg, where one is applied directly to this one, and complement is applied to the another one. So it works in that way, randomly only. At a time, if both are working together, that it doesn't make any sense. It will be acting as a single. So what we are doing actually, when we are alternating switching, we are converting the voltage into pulsating voltage. Pulsating voltage means now the transformer can work on that pulsating voltage. High frequency signal, no? It's a train of pulses actually. So pulsating signal means alternating signal. So that can be given here again coming, and again converting a pulsating signal into DC is very easy in compared to converting a AC signal, alternating signal, because there will be ripples like that. Here that will be converted ultimately into DC. Average value can come out to be like this. So the alternating, these two devices are converting DC into pulsating waveform. Pulsating waveform can be applied at the terminals of transformer, and then again rectified by the rectifier, bridge rectifier, AC, and AC given to grid tied inverter. So grid tied inverter operation I will show you later on. So now your doubt got cleared?
The PI value, we are using the transfer function of the this converter and
Yes.
But we are not taking any sensor from either the this converter would be output or the data current.
Which output voltage?
It's the transfer function.
No, transfer function always a part of the, what is in transfer function? These are the part of resistance, inductance value, I mean capacitance value only, no? So that those things are already given to you, and according to that you have to derive a transfer function, and from that transfer function you are getting the optimal gains. Ultimately it comes in the form of gains of P and I. So that theoretical part is going to convert into this PI only, no? So how now there are different way of getting the PI. So that thing need not to be mentioned over here, but ultimately it's a part of that. Here the main thing is that the photovoltaic systems can be controlled in that way. So control option is known to you, no? Transfer function because transfer function is circuit specific, plant specific. It cannot be generalized. For general configuration, it is just like that way of denominator. Of course, that is a part of my, so I have done everything in my paper. You can refer to my papers. You can go through my papers, you can get a lot of information from there. But that everything cannot be explained within the one slide, no? Okay. But you got the idea that how this MPPT is going to be utilized.
What is the
main connected is that how to means first of all that is high frequency transformers, so system is more compact. It is just like a compact DC converter in and the inductance requirement will be lesser in compared to a conventional buck boost converter. Gain is very high. In a normal buck boost converter, the gain of low voltage to high voltage DC is 2 to 3 times only. Here you can have n times.
You can multiply
And yeah, plus it is isolated from grid disturbance. Both the systems are isolated. So these are the advantages actually. Okay, now I have to revert back to the same. But just let me know you wish to go more on control side or what I should discuss. Means because time is also less, so you just tell me what in which part you are more interested. Control part, no? So I am coming directly to the control part of that. Okay. So these are some results. I don't need to discuss it here. So coming to the wind, so solar and wind, only the converter may be different. Grid side converter is same. So solar I have already discussed, DC-DC converter. So let's coming to wind turbine, AC-DC, and then how DC-DC converter. So wind turbines are having like a squirrel cage induction generator, DFIG, synchronous generator, or PMSG. These are the some conventional converters, controller schemes are there. In most of them, you are having soft starter and power factor control units here. But the controller which we are talking about, it is going to be bidirectional back-to-back converter topology, which I am going to discuss. So PMSG based. This is a DFIG configuration, well, where partial power can flow through the stator and remaining power can flow through the rotor. So rotor and stator both are having power flow. So normally this is designed 30 to 40% of the rated capacity, while 60 to 70% is power flow is taking place from the stator. So rotor is having full converters. So because the rotor is allowed to change its speed between 30 to 40%, so the speed variation of 30 to 60% is available. So you can change the speed of the machine to extract maximum power up to 30 to 70, 30 to 60, 40%. While in this case, it is fixed speeds or wind turbines. Of course, some gearbox is required to boost up the speed in order to reduce the number of poles of the machine or size of the machine. Higher the RPM, lesser will be the size of the machine or generator. Lesser the RPM, more will be the size of the machine. It is already known that hydro power plant, where the speed of the turbine is lesser, the turbine is bigger in diameter, lesser in length. But in thermal power plant, where the speed is much higher, the diameter is lesser and length is longer. It's only matter of accommodating the number of conductors and number of poles. Higher speed means lesser number of poles, more speed, lesser speed means more number of poles. So more number of poles means you have to accommodate more number of poles. So diameter will be ultimately going to increase. Lesser, higher speed means lesser number of poles. So lesser diameter is required. This is the only difference. So synchronous machine, then you are having bound rotor synchronous machines, diode bridge rectifier, AC-DC converter. So PMSG based DC-DC converter. This was my part of PhD also. So I have done this work only here. So this is the hardware setup which I also done in my lab while doing all the things. And this was the first sensorless vector PMSG control which I have introduced at that time, because I was having some project from ABB Montreal. So they were looking for wind turbine technology where sensors could be eliminated, especially the speed and motion sensors, because in very hostile operating conditions, though the sensors and connected wires can have some drawbacks. So if they can eliminate, then regular tier and maintenance could be avoided related to sensing. So sensorless control is going to be there. So okay, so commercial wind turbines have been fixed speed and variable speed topology. The variable speed wind turbines are more attractive as they can be operated at maximum power operating points over a wide speed range. Also, it reduces the mechanical stress on wind energy conversion system by absorbing the wind power fluctuations. Advancement in power electron devices further support the trend toward the variable speed turbines. And recently, the PMSG has received worldwide attention for wind power generation due to the small size, higher power density, high efficiency, and higher torque to inertia ratio. So coming to that part, so salient feature of the wind turbines, PMSG-based wind turbine, you know, that elimination of gearbox because it's a directly driven wind turbine. Variable side operation, speed operation for HMOCRER MPPT, enhanced fault ride through capability, high power density, and reduced copper losses due to the use of permanent magnet on rotor. And all these factors make it more efficient and reliable option, especially for offshore application where regular maintenance is least preferred. Because if you are having a gearbox and some both windings are there, so some losses are bound to happen in those cases. So problematic high installation cost due to the requirement of full capacity power electron devices, grid integration issues, voltage flicker, current harmonic and reactive power control, the control wind energy and fluctuating operating condition, voltage frequency control of grid, need of speed and position sensors for the vector control of PMSG. So okay, I'm just going to come into the system modeling. So now how the wind turbine is need to be controlled. So normally you know that the output power is a cubic function of the wind velocity plus area, swept area means rotor blades. So these are the design parameter. Only the wind velocity is the parameter which is out of control. So for a given turbine, design parameter are already given. That pitch angle and all those things are already, power coefficient is also given. So you have to operate that turbine according to the available wind velocity. So that means the power is a function of cubic function of wind velocity. So you have to only control that one. So different pitching angle beta 0 degree maximum, 10 degree slightly reduced power, and 20 degrees slightly for the reduced power. So different angles, pitching angle, yaw control and pitch control. Pitch control is within the blades. Yaw control is rotating the whole set of blades. This is yaw and this is pitching. Means changing the slight wings of the blades of that one. So pitching is there because sometimes you need to curtail the output power of the turbine also, because sometimes the wind speed may be too high. So pitching is required to maintain the output power within the rated limit, permissible limits of the turbine. And yaw control sometimes required when the wind speed are too dangerous that it can damage the wind turbine. So totally 90 degree, otherwise it's 90 degree. But when wind speed are very high, they will rotate and they will make it in the direction of the, they will align the face of the rotor blades in the direction of the wind. So in that way, they can avoid the high flow, high current of the wind velocity. So the power coefficient CP is a function of tip speed ratio, lambda, and pitch angle beta. So that's a different pitching angle may be there to reduce to make the system more workable. So there are different modes. Standstill operation may be there where no power is generated. Region first. Second is normal lower to maximum wind power. So this is the second region where you have to perform the MPPT. Actually, here the power is a cubic function of the wind speed. You can see the output power is varying with the wind speed, but above pitched or higher speed, you have to maintain it within the limit. So higher the speed, you keep on pitching. So that is known as pitched operation at higher speed. So modeling of PMSG, you know, that is the transfer part which we were discussing about. So we can incorporate all those things within the system. So modeling is there, where D part, Q part model is there. torque equation is there. So that means this is how we are going to control the generator side, and this is how we are going to control the grid side. So different switching sequence, and ultimately all the switching sequences coming in this way, they are going to means whatever power I am generating, the same should be transferred to the grid. If I am not able to do that, what will happen? My DC link voltage will keep on rising, and it may blast also. So it requires, it is just like pumping air into tire. If you are pumping more power into the this tire, it is bound to burst. So when a reasonable capacity is there, then it acts as a bridge. Whatever power is coming, the same is going to given to the grid. So that's why the maintaining the DC link voltage constant is essential. Once your DC link voltage is maintained, that means under the variable power generation, the power is being transferred directly to the grid because capacitor is maintained. If capacitor voltage is fluctuating, that means your regulator is not working perfectly, and the whatever power you are generating, either it is absorbed by the capacitor or it is raising the voltage of capacitor. So it is not going perfectly to the grid side. So power generation and power evacuation, that need to be synchronized, and that can be done if your voltage, DC link voltage remain constant. So DC link voltage status gives you an idea how perfectly your system is synchronized with the grid. And same thing happens with the ESD drives machines also. Usme kya, in that case, you are taking power from that side and giving to the motor. Here the power is coming from the generator and giving it to the grid. Both are same thing. Back to reverse power in reverse braking region, regenerative braking region. Same thing happen. So these converters are bidirectional power flow. Back to back converter topology. Are you there? So grid connected WECS is here. You are having back to back converter like here. These are the back to back converter. One is connected to PMSG with wind turbine and another is connected to the grid. So I have already told you that whatever speed at which your PMSG is operating and whatever ID and VD power multiply PDC, P omega curve. Oh, sorry, what happened? P omega curve. It gives you reference speed and actual speed. Both are given to a PI. PI gives you T, torque, as explained in the previous slide. Torque equation was coming. And that torque equation multiplied by this factor gives you IQ. Means torque controlling component. IQ. ID, you can keep 0 since it is a permanent magnet machine. So flux is already fixed. You don't need to regulate it. Otherwise, if it is a bound rotor synchronous generator or any other generator, then you could have changed the flux also. ID control may be required. That we call flux weakening or flux strengthening. If you wish to rotate a machine above its base speed, flux weakening is required. Otherwise, your terminal voltage will increase beyond its rated voltage. So flux weakening is required in those cases where bound rotor synchronous machine or DFI, double-fired induction generators are going to utilize. But in this case, it is a permanent magnet synchronous machine. So rotor flux is already fixed. You don't need to control. So ID you can keep 0. IQ is there just to control the torque on the machine according to the power. So ID 0, IQ is there, and theta is taken from here by from speed itself. By integrating it, you are getting the theta. So DQ to AVC transformation. So IA, IB, IC reference is coming, and actual IB, IAC, PWM. So this is pulse first for first device. This is for lower device. This is for second phase, and this is second lower device. This is for third phase. This is for third lower device. You are getting it? Every converter is having 3-phase converter is having 6 switches, no? Upper and lower. So first pulse will go to upper, second pulse will go to lower. Second will go to upper and its complement will go to lower, and third will go to upper and its complement will go to lower. 6 switches are there, na? So in that way, the pulses could be just like here.
Theta is same we obtained from the PLL block. So
No, this theta is different because in PLL block, theta is coming from the grid voltage. Theta is coming from grid voltage, but this theta is almost fluctuating with the speed. Omega is not fixed, na? In that case, omega is fixed almost. In grid side, it is 2 pi f. Frequency is almost fixed, so omega is fixed. So theta is also fixed. But in this case, because of the variable speed of the machine, the theta is always changing. So calculating theta in variable frequency mode is again a big challenge. So all these are the part of the research actually. So theta, how to calculate theta under variable voltage or variable speed condition. Just a grid voltage, if the grid is disturbance, having lot of disturbance, so calculating the exact theta, so you have to modify the PLL design. How fast your PLL can accurately estimate the theta. Wrong calculation of theta means wrong synchronization with the grid. So that means wrong injection of the grid. Sometimes it is having more active, sometimes more reactive part. Getting it? So that the part which I was showing you, upper pulse will go here, lower pulse will go here. For second, upper will go, lower will go. For third, upper, third, low. So similarly, on grid side also low, this one. So the 6 pulses which are coming out, originally they will be coming positive, and complement will be given to negative. So all these pulses are coming. So IA and IA comparison hysteresis loop, it will give you a pulse, and complement of that pulse given to lower. So IB and IB reference error is going to give you a pulse. It must be given to B phase of positive, and complement must be given to B phase negative switch, a lower switch. Similarly, IC and IC reference is going to give you a pulse, which must be given to upper device of the third phase, and its complement must be given to lower leg. Getting it? And the grid side, as I have told you, that you must have to maintain the DC link voltage constant at any cost. So reference DC voltage and actual DC voltage, reference DC voltage, and you given to a P, it gives you the amount of active power exchange which must be required under the given circumstances. Because on the one side, you are generating power, and on the other side, you have to maintain the DC link constant under the generated power. So it gives you an idea that how much active power must be injected in the form of current. Because active power injection means you only need to control the current, voltage already there. So in phase voltage vector template multiply by the peak value of the current, it gives you the reference current. So VA, VB, VC, that gives you unity template vector. UA, UV, UC, unity voltage pattern. You multiply with the peak of the active power component ID coming from the DC voltage loop. It becomes a sinusoidal current. Reference IA, IB, IC. So DC quantity up to this point multiply with their reference voltage vectors, it becomes AC quantity here, alternating quantity, alternating. Got it? And compared with their respective IA, IB, IC actual current, again it becomes the similar pulse and given to the switches. So in that way, the control or switching pulses. So all the control algorithm always comes in the form of switching pulses actually. And power electron device is the only means to utilize that switching pulse to implement your control algorithm. So ultimately, the speed regulator is converted into pulses only. DC link voltage maintenance, control of active power injection is converted into pulses only. So power electronics with their control circuitry, and this is the brain. It needs to be done in real time. All these calculations need to be done within a one switching cycle. Switching frequency means if 10 kilohertz is the switching frequency, that means 1 by 10 into 10 to the power 3. It comes out to 10 to the power minus 4 within 100 microsecond. Within 100 microsecond, all these calculation, right from measurement to calculation and everything, it must be done. Only then your system is going to work perfectly. Otherwise, next switching sequence will come. So all the measurement, all the calculations, everything, they need to be done within the same switching period. Otherwise, your control will be false. So sometime when you are doing the simulation, you see that your system is not working perfectly because there are so many things which need to be tuned actually. Inductor capacitor design, what must be the operating speed, power handling capacity, how the different blocks have been tuned to the same switching period. So what is your processing device? So everything had to be done in real time. This is called a real-time application basically. 100 microsecond or 10 microsecond is a real-time application. So within those things, you must have to do. Otherwise, you have to compensate for the delay. Compensating for the delay, deadband period. That is the period for which your system will remain uncontrolled. If you are putting intentionally deadband, in some control application comes some compensation, something like that. Some deadband calculation is also there due to the practical problems. But that during that deadband period, your systems remains uncontrolled. So stability of the system must be ascertained while calculating the deadband. That within that period, your system should not go out of boundaries, out of limit. Because during that period, that will be uncontrolled. And uncontrolled means the oscillations or whatever parameters there, they should not go beyond the permissible limit. So deadband calculation is also one of the important points. Because upper device and lower device, when you are switching on and switching off, the transition must take some time. Upper is coming low and lower is starting just like this one. So this period is very important. And multiplication of this period is going to give you a power. Positive power means some losses. So perfect deadband is there, means you are giving sufficient time to bring upper pulse low, and after some time this is happening. There is no mismatch. So power will be always 0. You are getting? Upper device is coming down, upper pulse is coming down, and lower device start turning on. So during that superimpose period, overlap period, the power will be there across the switch, which will appear in the form of switching losses. So soft switching, if you are looking for soft switching, you must have to give sufficient delay. Dual active bridge, DAB, have you heard about it? If some of you are working in that area, dual active bridge is having that concept. Upward these devices and these devices, they must be switched in such a way that there should not be any overlap period. So deadband is sometimes calculated actually.
So in the case of in the right side of the summation block, VDC is coming and VDC and giving the high current.
Yes.
So what PI is playing the role, how this difference between the DC voltage is coming out with the current and what PI is playing the role?
Actually, see, PI is a regulator. It is just like I can give you an example. Just like while driving a vehicle, right? When you are driving a vehicle, you are running at a, let us say, 60 km/h speed, and you wish to cruise at 90 km/h. 60 to 90 jana. So your reference speed is 90, and you are moving at a 60. You are having error. That error gives a plus 30 error. 90 minus 60, 30. So according to 30, how much fuel injection I must give to the engine, or at what speed I must put the put pressure on the accelerator. Accelerator is going to be given pressure according to that range. So my body, my eye on odometer, everything is acting as a sensor also. Because I am seeing, oh, I'm cruising at 60, but I need to cruise at 90. So as a human body, I am also involved in the control loop of the vehicle. Because I am seeing odometer is showing 60, I need to move faster. Okay, doing some calculation, and you are putting acceleration, and you are watching, oh, I'm going more than 90, or camera is there, I should just reduce it. So you are also loosening your grip on the accelerator a little bit. So perfect pressing and putting of pressure, putting pressure and keeping off the pressure, it is a kind of regulation depending on your error. If you are moving than 100, more than 90, error is minus 10. So you are taking up pressure. So it is a continuous tuning is required till you settle down to a 90 degree. So PI is also a kind of regulator where no human involvement is there, but depending on the circuit conditions, RLI, as this guy was already saying, depending on circuit parameters, already some optimal gains has been decided. And those optimal gains will always force the error to come to the standstill. And in order to make this error zero, they will always give you a amount of current. Current is nothing, it's a fuel. It is a fuel. In case of your vehicle, the fuel is change of fuel actually. The rate of fuel injection is a parameter, not the fuel. Fuel always need to be flowing either, but it has to be settled for 60 degree, some fixed amount of fuel, at 90 km, some fixed amount of fuel. But when you are moving from 60 to 90, the rate of change of fuel injection must be increased, and then fixed level of fuel need to be maintained to keep it at 90 degree. So rate of change of fuel, and here the amount of current to be injected or to be withdrawn. So in that way, the PI is giving the change of voltage. It is converting the error in voltage in the form of amount of current to be injected or to be withdrawn. Got it? Any issue or any discussion? Okay. So this is the generator side control. So as we have already shown that omega R reference and omega R speed given to PI regulator, it gives you TE. TE is again further by the formula, it gives you IQ. ID, you can the DEXC reference current component set to 0 in order to maximum torque at minimum current, and therefore minimize the resistive losses. So this is the how the grid generator side control has been achieved. And the grid side converter, I have told you that IMD is the reference VDC and VDC reference. It gives you the IMD. and then IMD is multiplied with the unit vector template, which is converted like this: VA over VF. VF is the root 2 3 VA square plus VB square plus VC square. So you are giving IA, IB, and IC. So in that way, you can control the circuit. So these are our results are. I will show you another way. So then optimal. Okay, just alert me when I have to stop.
We have 220 minutes.
So if you wish, we can keep for discussion, or you wish I can further keep on further. So this is the some sort of, so what I was discussing about optimal utilization of inverters. See, most of the inverters are underutilized for most so many times, because when I have worked, I visited one Kansas wind farm in US, and there I came to know that throughout the year, the rated output capacity, average output capacity is only 80 to 20%, and peak power is hardly 60% of the installed capacity. So on average, 80% of the nameplate was available, and during the peak hour, 40% the power electron capability was available. So at that time, they were also having issues with the conventional wind power plant, because in North America, especially in Quebec area, upper region, they are having self-excited induction generator based wind turbines also. And those SCIG are drawing more reactive power. And that reactive power need to be fed by grid if there is no converter. So they were looking for a study where if retrofitting of SCIG done, and those SCIG could be replaced with the help of PMSG based wind turbine, where full-fledged power converter topology is there, and the power converter can be also utilized for sorting out the reactive power compensation of nearby SCIG or load or some other thing. So that kind of study was going on, and at that time I have suggested that why we are going to install STATCOM, we can utilize the converter which is going to utilize for evacuating power, grid tied inverter. That inverter itself can meet the reactive power load demand or harmonic compensation or any kind of thing. So that kind of smart concept which I have introduced in the system, and now it is a standard worldwide. I got almost more than 630 citations for this paper. It is in power delivery, grid integration of renewable energy sources at distribution level with power quality improvement feature. Power delivery in 2010, I think. And it was one of the most cited paper within a year. 100 citation got in 1 year. IEEE citation. I'm not talking about any other citation. So if you guys are more interested, you can refer to that paper also. IEEE power delivery. I will show you the references. So we have introduced this concept that because in earlier case, what happens if you are generating only the active power, and some load is already there which is consuming active power as well as reactive power plus some harmonics. So grid is now going to be more polluted, because PRES minus PL, active part shared by the grid is very minimal now, while the whole reactive part and harmonic part is to be shared by the grid. So in case of this scenario, the grid is more polluted because it is sharing very less active power, while rest of the low active power demand of the low harmonic component of the load, allow the reactive power of the load had to be supplied by the grid. So grid was on losing side, because the most of the power coming from the PCC at the point of common coupling, जैसे rooftop पे आपका, if you are having a solar power plant installed, you are taking active power from there, but you are drawing the rest of the reactive power and harmonic from the grid. So in that sense, you are polluting more it. So renewables were creating more trouble. So this thing I have pointed out, that why we are so this due to intermittent nature of wind, the installed grid interfacing inverter rating is rarely fully utilized, and the expected wind power output is nearly 60% of rated capacity. yet the annual capacity factor may be 20 to 30%. And the WCS are supposed to supply only active power, which may result into the increased grid pollution due to the non-linear unbalanced load at the point of common coupling. So that was the thing that we need to understand. So what I suggested that if I can control the inverter in such a way that it can supply the generated power, PRES, which it was generating in previous case, plus this part also from the inverter. Then grid side, I am having the only the exchange of balanced active power, means deficit amount of. If I am generating less from renewable and then consuming, then I have to take some power from the grid. Or if I am generating more then I have to give power to the grid. So only the exchange of active power will take place, while the harmonic and reactive power have to be taken care by the generators, grid side, that grid side inverter, or grid interfacing inverter, renewable interfacing inverter. So that is the change. So you see that now my grid is more balanced, more healthy, because it is only exchanging the active power. Reactive power demand, because you have to supply whatever load you demand. You cannot change the profile of the load. It is just like a market. Whatever market is demanding, you have to supply it. So the pollution part is also going to supply from the renewable side. So grid is pollution free and it is only concerned about the active power. So this is the smart concept which we have inbuilt inside this. So here the main objective is the optimal utilization of inverter rating by adding active power filter features to it, so that only the exchange of balanced active power takes place on the grid side. The inverter is controlled to perform the following tasks simultaneously: generated active power injection, PRES, load harmonic compensation, that is PL oscillatory part, and load unbalanced compensation, that means whole reactive power demand of the load, and load reactive power compensation also, unbalance also. And so all those four parts I have inbuilt it within the same converter. And this was the voltage Session-12 compensation which I have done with the help of this. So this is the grid voltage fluctuation, but the nearby load is fed at almost constant voltage. I will show you the harmonic part also. This is the unbalanced part which I have controlled. So this is the three-wire nonlinear system. This is the control part. So what I did in VDC PID, I further modified it for the harmonic part. I'm utilizing the harmonic part also in this case, VDVQ, and this is the grid side control, because generator side or renewable side control remains same. Only grid side converter need to be compensated. So this is how we are seeing. See, this is the you can say grid voltage. This is the load current. So this is how my generator is giving, inverter is giving current, so that the grid always having the sinusoidal current, exchange of sinusoidal. And this is the experimental result, that this is the load current profile. This is the means when it is generating only, when it is generating less, the grid is supplying some power actually, but the phase reversal takes place when it is generating more than the load demand. So the grid current is now fed into reverse direction. You see here, peak are positive peak and negative peak. Positive peak, negative peak of the current voltage, and positive peak of the grid current. That means phase reversal, means power is flowing back to the grid. But this side, they are in the same phase. Same phase means you are taking power from the grid. Phase reversal means you are injecting power into the grid. And at this instant, for momentary, this is zero almost, because the load current profile is almost equal to the this profile. So if you apply KCL, you will got the things understand. So this was the 3-phase 4-wire system. So again, I just modified here a little bit because fourth means unbalanced current is also there. So what we did, that unbalanced current, neutral current is also shared by this neutral wire from here. So the grid is always having a perfect 3-phase system, perfect balanced load. So I will show you here in next slides. See, this is phase A, phase B, phase C. All the loads, phase A, phase B, and phase C, they are different. Inverter current injected are also different. What remains same is the grid currents. They remain same. So it indicates the grid voltage capped, grid current, load current remains perfectly balanced, while the unbalanced load is supplied from the inverter. And this is the neutral conductor wire I. The whole neutral requirement of the load is supplied from the inverter. That's why the grid side neutral current is 0. And 0 neutral current means perfect balance. So grid side neutral current is 0 because the unbalanced part I am supplying from the inverter itself. So load unbalanced part I am supplying from the inverter. So that's why these are the perfect balanced volt current. These are the unbalanced part which I am supplying. This is the unbalanced load, unbalanced inverter injection, but these are the balanced grid side current. Are you getting it? And this is evident from here. Inverter is giving just a complement of the load. So this is becoming 0. So this is the experimentally which we have achieved at that time in my lab. So all the advanced control algorithm are there. I think that I am not supposed to discuss over here. This is all the same page. Power electronic converter there. Some sensorless topology. Yeah, this you can see experimental results I have taken for this. See here, 3-phase unbalanced load, 3-phase 4-wire unbalanced load. But once inverter comes into picture, it becomes the neutral current becomes perfectly 0, and all the phase becomes equal.
For 3-phase unbalanced load, we have the mitigation techniques, several mitigation techniques to balance it. We don't need inverter also. We can balance it directly using capacitor and inductor.
But that is not active, no? That is not active power. You can only this is a passive element, no? Or they will do in steps. Here it is perfectly balanced, and the converter itself is being utilized. No additional device is being injected. No additional device is being introduced. It is the same inverter which is there to evacuate the power. Okay. So those passive devices, they can compensate only steps. But here they are active devices. So that is the beauty. Actively, even within a switching cycle, you see what a smooth transition is happening. The moment I have introduced the inverter with the harmonic filtering capability, same thing happened here. So this is the phase A, phase B, phase C, and this is the neutral current. And here you have unequal current I am giving. So this is the case. So all the papers you can go through some of my reference. So this paper is these 3 papers are more important. And then here is also some papers. All these slides are based on those only. And other references are also there. If you are further interested, you can all these slides, all the things material is available in this paper. So any doubt, please ask.
Session is open for participant. You can ask some question.
Starting, you have said about the maximum power tracking of wind power plant. How is it different from solar and DTU?
Both are same thing actually. In ultimately there the power is function of the voltage output solar plant, and here the power is function of wind speed. That is the only difference.
Voltage, current, and speed, all three, or
No, the power is function of cubic, because for a given wind turbine, the CP is fixed, which is a turbine specific parameter. So that is a hardware parameter. For a given turbine, these parts are fixed. So only the output power will be dependent on the wind velocity for that plant on a given operating day. So solar plant is also same. There all the internal characteristics are same. The power plant is not going, the panel is not going to change. What is going to change with the radiation fall? The output power or voltage is going to change. So P is a function of their DC voltage, and in case of wind turbine, the P is a function of wind velocity. That is the difference only.
in P and O, we changes voltage, in solar changes voltage and current.
So here you are changing the according to that you are changing the speed of the turbine. P actually from P omega curve you are getting the omega reference. From the omega speed you are getting the reference P and actual P, and you compare and then you are getting it. Here. You don't know.
Sir, how to find the appropriate controller for
Grid synchronization is done through PLL only. Through PLL, there is a two kind of things. One is if the grid is polluted, then calculating the accurate theta is a big issue. So under those things, you can go for detailed PLL or other PLL where under the variable operating condition, the theta can be easily calculated. So otherwise, the theta, I can show you one diagram also. If you are going to calculate the theta, actually this is theta, which I have calculated for the generator for a given voltage. This you can also calculate for the, this is just for variable speed operation actually. But if you are having you see, during transition period, there is slight deviation, but when steady state, it becomes perfectly triangle. So when it is changing, during changing, the variation occurs in this range. The error, you see this error with the transition. This error with the transition. You see speed error, as well as the PLL error will be there. So during transition or fluctuating condition, it is very difficult to capture the actual theta. And for that purpose, you go for different advanced algorithm. But normally what we are doing, we are developing too much complex algorithm that the computational times increases drastically, and within one sampling time period, you are not able to get it rightly. So that's why sometimes we are developing more complex algorithm. It may not help you to get the best result or desired result also.
So can we say that using smart grid is safer? We can totally depend on the smart grid for the power supply or not? Is safe for us or not?
See, that is a question of debate actually. If your system is almost very smart and no human intervention and nothing is involved, it's done automatically. Sometimes they are prone to attacks, cyber attacks, because ultimately it's a data, information of different voltage sources, and everything is going to be synchronized through PMU and given to a big data warehouse or where we are controlling it. So while transferring the data and everything, it depends on that. If safer your approach, more accurate will be your system operation. Otherwise, it is going to be a disaster actually.
So in that case, if the smart grid get collapsed, then in that case, we should depend on the conventional resources.
So that's why we are having concept of microgrid.
It is also some kind of smart grid. We are
No, smart, but confined to small geographical locations. So a hacker may not be interested in putting after the whole energy grid got hacked. Then within the small pockets, ultimately you can keep on meeting the load demand at dispersed locations. So how many by that time your other protection and those mechanism will come into picture. So at least it gives you time. Just like during some climatic condition, earthquake or something, whole transmission line got disturbed, and you don't have any access to the electricity grid. So in that case, if you are having a battery vehicle or any other thing and smart device, you can keep on energizing the local demand. You can keep on running the pumping station or something, water injection system, something. So in that way, the smartness is definitely going to help you. But when coming to big picture, definitely you have to make it more secure. So data security is one of the major issue which is being taken care by so many things. So you know that recently AIMS database has got hacked. The patient database, doctor's database, who was assigned to which patient, what was his medical transcription records, everything got disrupted. And then they also find some means, and now they are taking care of that. So everything comes from the lesson experience what we are having from daily routine. So these things are going to be a matter of discussion, but they should not be a hindrance in the development of anything, because everything has pros and cons. So you have to make a better focus on pros and while tackling with the cons also.
As you said, that's in the wind, WPD induction generator has been done. The power supply, the 30% of the power supply is fed from the rotor side to the grid, and 70% from the battery to the grid. Then why we can't transfer 100% from the stator to the grid? Why we are using 30%?
See, if we are supplying whole the 100 power through the stator, then it is just like a SCIG.
Why we can't do
Variability we are introducing, variable speed operation. If you are transferring 100% power, that means it is synchronized with the grid voltage. So no change in speed. Fixed speed operation will be there. So that is making it you cannot perform the MPPT. Variable speed turbines are coming in picture only because of their popularity, because they can extract the power, maximum power at different wind velocity. That 30% variation gives you sufficient capability, because the wind is also not varying from 0 to 100. Sometimes it is maybe 5 kilometers, sometimes it can be 10 kilometers per hour or per meter. So that can be the speed range. So 50% fluctuation in wind may be there, which can be easily taken care by DFIG, and that's why the 30 to 40% power electron capability is required. Otherwise, if you are going to full variable capacitor of wind turbine, just like a PMIG based wind turbine, where the whole large scale, full scale back-to-back converters are required. So if you are having whole power flowing through the stator, no variation over in speed, because rotor is controlled by the back-to-back converters only actually. And rotor is the only mechanism which is controlling the speed of the turbine. So variable speed operation.
So in the case of PMSM we are using, then where this 30% energy is going in case of PMSM? In the case of
Nowhere, it's simply converting AC into DC, and then everything converting to DC, then converting to AC. So its whole power is going back to that.
So there is system consists of a photovoltaic, a full cell, and battery supported system, and it is islanded from an EV.
And it is
islanded macro system.
okay.
DC power. There is no interface in the inverter. So we can maintain the voltage by using the closed loop DC, by using tether. But there is a change in the load. So there is no regulation in the current level.
Yeah, current ripple will be always, because it's an inertial system, na. You can have rotary inverter in that case.
So we have two options. Either we have very additional sources, or there is to compromise the capacity of the sources. If all the sources utilize their full capacity, so there is no third option. So we have to mitigate or effect in the case of the load side.
I have explained you one classical example of solar pump. I have shown you that it depends on how accurately you are looking for the regulated output. If you are looking for regulated output, you have to go for the sufficient battery energy storage system or some alternate device. If you are going for unregulated control, they are just like a solar pumping water station. Whatever solar power is being generated, according to the motor is going to rotate, and accordingly your output power water coming from the tube pipe is changing. So it depends on your load requirement. If your load, if you can tolerate the load fluctuations with the voltage fluctuation, that's fine. If you are looking for perfect control, then definitely you need to have some other backup. You cannot manage by this simple load and solar photovoltaic. You cannot do with that. Are you getting it? That's why hybrid system, battery energy storage system is required.
That means if I have to maintain the voltage level simultaneously with the load current, so system must be operated below their capacity.
Yeah, exactly. Otherwise, you know that if you are utilizing over capacity, then there is no option. You don't have backup, you don't have sufficient generation. What will happen? That is a mismatch condition, na? P is equal to PD. If it is not equal to, mismatch will happen always in terms of voltage and frequency fluctuation. That's it. Very simple. Yes, please. Any other?
In case of theta, you told that the theta is from the electricity from the grid. What if we take the voltage to the PLL, we give the generating side?
No, you can, then generator side operation will be faulty operation, because it is synchronized with the grid current, grid theta. Here the purpose is to operate the speed of the generator. So you must know at what speed actually it is rotating. So if you are giving him wrong theta, so wrong speed operation will take place. So that is not desirable. Means the system which you wish to control, only those parameters will be given. Na? It is just like that. See, he is also sick, you are also sick. He is having different illness, you are having different illness. Whatever prescription I have given to you, I am also giving the same tablet to you. Is it going to work perfectly? Both are having different issues. Both need to be given. So your parameters are different, his parameters are different. So the prescription should be given according to the whatever the parameter you need to regulate. Fever आपको है, दवाई उसको दे रहा हूँ मैं. Are you getting? Speed regulate मुझे टरबाइन का करना है और थीटा में ग्रिड का लूंगा, तो how it is going to help? No, वो तो that will not work. In future, yeah, there are also there are now in Indian scenario, I can tell you, because I am also involved with the Ministry of Power. So there are also 2-3 players. Adani is having their different transmission line network. Adani Power, they are having their own dedicated transmission line network. The power being generated over there, it is being sold in Haryana directly, and that highway which they have done, it is only transferring the power from there. So people are already having that network. Now a green corridor is going to be there. We are going to install a lot of solar power plant in Leh Ladakh region where load is not there. Only generation is there. But then their power have to be to transfer to the bulk power consuming city like Delhi or Chandigarh or maybe in Punjab somewhere. So long dedicated transmission line, dedicated green corridors are going to be developed, and a lot of public-private partnership, BBB format is coming in that way. Government is also providing incentive to the people who are involved on those projects. So it is a, it's a policy making decision which had to be taken on government to government basis. But definitely the things once got implemented somewhere else, and the people look for the benefit, and then those things are going to be implemented somewhere in other parts of the world very soon. So later or sooner, the things are moving toward the USA. Whatever is happening there, we keep on, that development comes and we keep on following. That is the recent scenario here only. So things, deregulation comes from here through World Bank. All the Genco, Transco and Discoms came into picture. Otherwise, before that, it was full electricity boards. And now the transmission company different, generation company different, Discoms are different. Within Discoms are UHBPN, DHBPN. There are different Dakshin Haryana with the Prasaran Nigam Limited, Uttar Haryana with the Prasaran Nigam Limited. So it depends. I don't know from which country you are. From where you are? Ghana. And you? Kenya. So in Kenya and Ghana also, if you go and see over there, they will also change their system will also going to change after some time. So it's a transition phase, evolving situation. Things are still not very mature or materialized, and that's why they are more challenging and interesting also. That's why people are going in. Still, EV is having a lot of challenges, but still, the things are not get settled down. Once they get settled down, then some next thing will come. So it's always changing scenario where you have to keep on improvising. Okay. So guys, thank you very much for giving me ample opportunity to interact with you. And you have been really very peaceful audience. You keep on listening me for so long hours, almost 2 hours without any disturbance. So either you were not able to understand anything or you were understanding everything. So that is, so anyway, based on your interaction or feedback, I can ascertain that you were really interested in the talk, and I hope you got benefited, and I have answered your question up to the maximum satisfaction. If still you have any doubt, my email ID is with the Professor Shivam, and my contact number, you can visit website. You can see my name over there. My references are also there. So you can, or if you go through my paper, you will automatically understand. These are very clearly, crisply written. That's why I'm having most satisfaction from IEEE transactions only. Not those, because you can easily correlate the things. Because the way I understood, only that way I write the things. I keep myself on the lowest hierarchy of understanding level. And according to that, I keep on building on. So you can also understand from my delivery of lecture that I start from very basics and then I can go up to the maximum level. So it depends how much time of interaction is there. According to I can manage. I can deliver the whole day also. It depends on your interaction. Because on a single slide, there is so much content only. Here I have tried to make you slight glimpses only. Okay. So thank you very much, and thank you, Shivam.
Thank you, sir. Thank you so much, sir. So, participants, we will meet in the next session. We will start it from 2 o'clock today. So, for accepting invitation to the sir, thank you, sir. You have given chance, opportunity for us in the busy schedule. So for that, thank you, sir. Thank you all participants. You have asked many questions. Thank you to everyone.